Hi guys, I am Yashodhan Agnihotri, a final year student at IIIT Pune, and I will be your host for today. Welcome to our channel, Learn Competitive Programming with CodeChef. On this channel, we post weekly problem explanations and concept videos. Also, if you are interested in competitive programming and want to master data structures and algorithms, this is the place for you. So, what are you waiting for? Click on that subscribe button and kickstart your journey towards competitive programming today. So, the problem that we are going to discuss today is sweet rectangles. This problem appeared in the December Cook Off, and the difficulty level of the problem is medium hard. The prerequisites for this problem are observation and implementation. So let us see the agenda for today. First, we will try to understand the problem statement. Next, we will see the solution approach. Lastly, we will see the C++ implementation walkthrough. So let us try to understand the problem statement. So basically, we are given a rectangle of size n into m, where n comma m is less than equal to 1000. So we need to count the number of such rectangles so that one of these following conditions should hold. So one of these conditions should be true. And what are the conditions? Say we have a rectangle with coordinates A, B, C, D. So these are the sides. And so basically here every coordinate has a candle of height h. So say height over here is AH, here it is BH, here it is DH, and here it is CH. So what should be true? That both AH and DH should be greater than both BH and CH, or both BH and CH should be greater than both AH and DH. So for example, 5, 1, 3, 4. So this is a good rectangle. So now we have been given q less than equal to 10,000, where we update a particular cell to a different value. So these are the values given to us, and we have queries where we can update the value of a particular cell. So after every such query, we need to output the new number of such rectangles. So basically now here this is a sweet rectangle, and suppose I change the value of 4 to 2. So in this we do not have any sweet rectangle. Okay, so we have to do this for every such query. Now let us see the detailed solution approach. Also, did you know that CodeChef conducts free live classes on Unacademy, where we teach every possible topic related to competitive programming? We have basic level courses like Introduction to C++ or Java, Recursion, Basic Data Structures, as well as advanced level courses like Dynamic Programming, Segment Trees, and Graph Theory. These courses are conducted by top coders who have been ICPC finalists, IOI medalists, or work in top product-based companies like Google, Facebook, and LinkedIn. All you need to do is download the Unacademy app or register yourself at unacademy.com and choose your goal as competitive programming. You can also take the paid Plus subscription to get additional features and individual level support. In Plus, we have a large set of practice problems associated with every topic covered. Also, we have 6-star and 7-star rated teaching assistants to help clear all your doubts before, after, and during the live session. You can use my referral code, which is ZAP10, and get an instant 10% off on Plus subscription. So hurry up guys, don't miss out on this amazing opportunity and kickstart your journey towards competitive programming today. So let us move on to the solution approach. So basically, what is a sweet rectangle? So let us see, we have a rectangle, say A, B, C, D. These are the heights of these 4 points. Okay, so basically a sweet rectangle can be one of the two types, that A and D is greater than B and C, and or B and C is greater than A and D. So basically over here, let us see how these rectangles or how these heights will look if we sort them in ascending order or say descending order. So here A and D will be adjacent in the sorted order, and B and C will be adjacent. So how is this? So let us see what is a valid rectangle. So I think 5, 1, 3, 4. So this is a valid sweet rectangle. So now over here 5 is greater than 4, greater than 3 and greater than 1. So 5 and 4, so this is A, D, and 3 and 1, so this is C and this is B. So what we said over here, this holds true with respect to the sorted order. Now let us see how we can use the sorted order to our benefit in this question. So by looking at the solution so far, we can say that it is easier to calculate the bad rectangles. So how can we calculate the number of good rectangles? So it is easy. So total minus bad rectangles is equal to good rectangles. Now let us see how we can calculate the bad rectangles. So for a bad rectangle, we need A comma D or B comma C not adjacent, right? Because as we saw earlier, in the sorted order, A comma D and B comma C will be adjacent. So now let us try to calculate the number of bad rectangles. Let us see what is the condition for a bad rectangle. So now we have the rectangle. So A, B, C and D. So now let us fix the point A and let us just focus on these 3 points. So now we can write a condition like B less than D less than C. So this is condition 1, and the other condition is that C less than D less than B. So if you see in these two conditions, no matter where you insert A, it is always a bad rectangle. So now let us try and see A, B, D, C. So here I am inserting A at the first position over here. So this is a bad rectangle because B and C are not together and A and D are also not together. So bad. Now let us see that let us insert A over here. So B less than A less than D and less than C. So this is again a bad rectangle because B and C are not together. So if you check wherever you insert A, it does not matter because in all of these cases, so here basically there will be 4 cases and 4 cases. So in all 8 of these cases, it will always be a bad rectangle. So actually you can work this out for each case and then you can see. So now holding on to this 2 cases and this observation, let us move towards the main solution. So let us see the observations we have made till now. So the first is that we need to count bad rectangles. So because counting bad rectangles will be easier because of the conditions that we saw. So how can we now calculate the good rectangles from the bad rectangles? So good is equal to total minus bad. So what are the total number of rectangles? So it is pretty easy. It is just NC2 into MC2 because it is obvious that among the rows we will choose any 2 points and among the columns we will choose any 2 points. So NC2 into MC2 are the total number of rectangles minus the number of bad rectangles. So this is nothing but n into n minus 1 by 2 into m minus 1 by 2 minus bad. Now the second observation that we saw is the condition that we saw which was that we are first not caring about A over here and we wrote something like this. So this is one of the conditions for a bad rectangle, and another such condition is, so what can we say from here? We can say that there are exactly two corners in a bad rectangle such that, so say this and this are the two corners. So basically this has a higher value and this has a lower value. So there are exactly two such corners in a bad rectangle such that one adjacent corner is high. So it is high, so I'll denote it by plus, and the other is low. So it is minus. So these are the two observations which we saw till now. Now let us try to count the number of bad rectangles. So for counting rectangles, we can just calculate how many rectangles each corner is a part of. So this we are talking about bad rectangles, and for this we can use sorting orders. So basically we need to sort like say in a tuple of say height I comma j. So this is the height of the candle placed on the coordinate, and these are the two coordinates. So we have to make use of the sorting order. Then we can use simple counting along rows and columns. So simple counting along rows and columns. But in this there is a chance, or there is a probability that we will be double counting. So a rectangle has four corners. So and we are basically counting the bad rectangles, right? So say we are counting B and C over here. So we will double count a rectangle. So in the end, we have to just divide the total count by 2. And here, yeah, simple counting along rows and columns. So we have to multiply them. So this should be noted. Now let us proceed to the next part of the solution. So for each query, we can just do a linear scan across the row and column to remove the previous rectangles that were considered. So consider that in this there were some rectangles that the corners were a part of, and they were considered in the previous answer. So we'll say that as P ans. So we should just remove the previous rectangles that were considered, and we should add the new rectangles. So here, but there can be a problem, as here we are actually updating one of these values, right? So the sorted ordering of the row and column, it will change. So make sure to update sorted ordering as well. Now let us see an alternate approach of the same question. So in that approach, we will be counting the good rectangles directly instead of doing total minus bad rectangles. So let us see how. Let us see the alternate solution. It is based on the fact that how to calculate or how to directly count the number of good rectangles. So here we need to just count corners which are greater than both the adjacent corners. So if we can see, so there will be two such corners for a good rectangle, and there will be one such corner for a bad rectangle. Now let us go to the next step of this solution. So for this alternate solution, there is no need to maintain a full sorted order. We just need to maintain the count of how many cells are smaller or larger than the current cell in its respective row or column. So now we have discussed both the solutions, and now we will proceed to the C++ implementation walkthrough. So let us see the C++ solution for this question. First, I've taken input n comma m, the sizes of the matrix. Here I've declared the necessary implementation vectors, and here is the row count, column count vectors. Now here I am taking input the matrices, the matrix elements, and here I will be pushing them into a tuple of 3, where the sorting order it shall be maintained. Now here there is a total which is n into n minus 1 into m into n minus 1 upon 4. So it basically represents nc2 into mc2. This is the exactly the procedure that I have described in the video solution. And yeah, so basically this solution will be available in the comments, so you can refer to this solution for further information. So this winds up our solution. Now let us submit this and let us hope for a correct answer. So we got a correct answer. Thank you for watching this video.